So 5.2, we are starting today. We will continue working on it tomorrow. Tomorrow the problems will be just a little bit more difficult. So we are going to solve a system of linear equations by substitution. Okay, we're going to skip the warm-up since we did that word problem that had us graphing a system. So you can cross out the warm-up. Or you can do it later for extra practice. That's fine too. Anybody need more time getting their objective written down? Okay. To review what we talked about yesterday with systems. A system of linear equations is a set of two or more linear equations with the same variables. Okay, we still have those same example system equations that we had yesterday. Again, the solution of a system of linear equations is an ordered pair. That's a solution to both equations. Both of them at the same time. That's all stuff we talked about yesterday. So technically you could have copied those blanks over from yesterday's notes if you had it filled out. For the substitution method, we've got a couple options. They end up being very similar. The first option is to solve one of the equations for x, then substitute into the other equation and solve for y, then substitute y back into your original equation and solve for x. Okay, so the substitution methods usually seems to be the hardest for students just because of the flip-flopping. You're solving for x, then you're solving for y, then you're solving for x again, then you're plugging it in here and you're plugging it in there. Okay, so these steps can get a little confusing. We'll take it one step at a time. Okay, solve one of the equations for x is the first thing it says to do. Lucky for us, that's already happened in this example. Which equation is already solved for x? Where is x already alone?
X equals y plus 1.
Good, x equals y plus 1. This equation is already solved for x. X is alone. We are going to substitute into the other equation and solve for y. So this is the tricky part. Instead of writing an x here, I'm going to rewrite this bottom equation and I'm going to put a set of parentheses where x used to be. So instead of putting an x, I'm going to put parentheses there like a placeholder because we're going to put something else there instead. Instead of an x, we are substituting in what the other equation said x equals. What did it say x equaled? Y plus 1. Okay, if you can get that step, then hopefully the rest of the problem won't be too bad. That's the tricky part about it. Okay, one of the equations has x alone. You're going to take whatever x equaled, so in this case that was y plus 1, and plug it into that x. Why do you think I put the parentheses there? What do you think?
Because on the side of the two variables are x, and then on the top it says x equals y plus 1. So you have to multiply.
Good. What word have I not heard that you think I'm looking for? Goes along with multiply.
Division.
Distribute. We have to remember to distribute.
2y 2.
Okay, so yes, we would end up with 2y plus 2. That's a big reason why I use parentheses as my placeholder. You have to remember to distribute. So now we're on to the part where we solve for y. Bless you. Okay, we're on to the part where we solve for y. That means we have to distribute. 2y plus 2. This 2y comes down. That's still there.
And the 6 comes down.
This equals 6 comes down also.
And then you do 2y plus 2y, 4y plus 2 equals 6.
Okay, combine like terms. 4y plus 2 equals 6.
Minus 2.
We're trying to get y alone.
Sorry.
So we've got 4y equals 4 now.
Divided by 4, y equals 1.
Good. Divide both sides by 4. We have that y equals 1. We are not done. We're getting close. Do we have questions so far? Okay. So the next part says, then substitute y back into your original equation that was solved for x. So we're going to take this y and put it back in to the original. So that 1 is traveling all the way back up here and going in for y. Okay, so now we're going to have that x equals 1 plus 1, which is 2.
Wait.
Questions about that step? Okay, now technically we have shown all our work. We just need to write our answer. How do we have to write the answers to systems of equations? Dominic, what do you think?
2 comma 1.
2 comma 1 inside
A parenthesis.
the parentheses. We write it as an ordered pair. 2 comma 1. Questions so far about the substitution method? Okay. The other way of doing it is pretty similar. Just swap all the x's and y's. Okay, so the other way of doing it is to get y alone, or solve one of the equations for y. Then substitute into the other equation and solve for x. Substitute x back into the original equation that was solved for y to solve for y. So this second option, all we're doing in the directions are switching where we had x's and y's from the last one. This one's nice because they started us out with one that was solved for y. Which one is already solved for y?
Y equals 2x plus 1.
Good.
1.
So we've already got y alone here, which means we're going to take the 2x plus 1 and plug it in for y. You've got to make sure you're plugging it into the right spot, otherwise it won't work out. Now, I, out of habit, always put parentheses where I'm plugging something in. Do I really need the parentheses this time?
So it'd be, will it be 2x plus 1 in the parentheses?
Yes. So the 2x plus 1 gets plugged in there. Do I have to have the parentheses there?
No, but it's good.
We don't really need them because what number would be sitting in front of this y or in front of these parentheses? What number is in front of that y? A 1. And if I distribute a 1, is anything going to change? No, multiplying by 1 doesn't change anything. So we could just drop the parentheses. Okay, multiplying by 1 isn't going to change it. Questions about the substituting part?
Hold on, I thought you was do 3x times 2x.
No, we only multiply whatever's right in front of the parentheses, which in this case would just be a 1. So the 3x, yep, stays out in front. Good. All right, we got to combine like terms, which means we end up with 5x plus 1 equals 11. Subtract 1 on both sides.
5x
5x equals 10 when we subtract that 1, so x equals 2 after we divide. What are we going to do with that 2?
Plug it back in.
Plug it back in where?
The original problem.
To the original problem for x. So we're taking that 2, and it's going all the way back up here and going in place of x. So we have y equals 2 parentheses 2 plus 1. Order of operations means we should multiply first. 2 times 2 is 4 plus 1 is 5. Your answer should be written as an ordered pair x comma y. So I don't care which variable you solve for first or second, your answer should always be x comma y. Questions about this one? Okay. Ready to try another one?
No.
Why not?
We're tired.
Oh. Well, time to wake up. Here we go. On example 3, we've got 2 equations. This one, for whatever reason, some students think is tricky. In my opinion, it makes it easier. What variable is already alone? Y. And it actually happens in both equations. So y is already alone in both equations. What that means is that we can take this 1/2 x plus 3 and plug it straight into the y of the other equation. We don't need any parentheses because there's nothing getting multiplied to this y out here. So we can go straight to having 1/2 x plus 3 equals negative x plus 6. Questions about substituting into the y? Okay, the other way this problem is different is that we have x's on both sides of the equation. We need all of our x's to be on the same side. How could we force that to happen? For example, if I wanted this negative x to go away and move over to the other side, what could I do to it? Add it. We could add a 1x to both sides. Okay, we do have a little bit of fraction work here. If we have 1 plus 1/2, 1 1/2 as a fraction is 3/2. If you have a calculator, that might make it easier. Type in 1/2 plus 1. We're still adding 3 on that side. What do I still have on the right side? A 6. Still solving for x. What should I do next? Subtract the 3. 3/2x is equal to 3. Who remembers how to get x alone when it's getting multiplied by a fraction? Dominic? Use your reciprocal. Multiply both sides by the reciprocal, which would be 2/3. On the left side, what happens with our fractions? Cancel each other out. We just have x. On the right side, I could put this 3/1. What happens to the 3's? They can cross cancel. So we're left with x equals 2. 2 over 1, or you could just put 2. Questions about solving for x? Okay? After we solve for x, we are going to take that number and pull it all the way back up to the top and plug it in for x in the original problem. Which means we would have y equals 1/2 parentheses 2 plus 3. All right, we got to simplify this. What is half of 2? 1. 1 plus 3 is 4. We're done showing our work. We just have to write our answer. What is it? 2, 4 as an ordered pair. Questions about example 3? All right. Example 4 is the same kind of thing. We are going to take this expression that y equals and plug it into y in the other equation. So instead of writing y equals, I'm going to put x plus 2 equals negative 2x plus 5. Questions about substituting? All right, we got to get all of our x's together. Who can tell me how to make that happen? Jamila? Add what? Good. We could add 2x to both sides. X plus 2x gives me 3x. What do I still have on the right side? A 5. Once we get here, everybody should be comfortable with this. We need to subtract 2 and then divide by 3. What do we get for x? 1. All right, we found one variable, so we're going to take that number and pull it all the way back up to the top and plug it into x so that we can find y. What does y end up being? 3. Always write your answer as an ordered pair, x, comma, y. So this time it is 1, 3. Questions about solving example 4? Need more time on this slide. All right, move on. Example 5 is a little bit more similar to what we were seeing when we were given the steps. So like on example 2. What variable is already solved for us?
Y equals 6x.
Okay, the y is already alone in the top equation. So we are going to take the 6x minus 11, and where are we going to put it? Good, we got to put it into the y. So always look for what variable's alone. That's where that expression gets plugged into. This time it will be important to have parentheses where the y was so that we remember to distribute. So in those parentheses, that's where I'm putting the 6x minus 11. Questions about the substituting part on this one? Okay. We need to distribute. What you need to be careful about with distributing this is that we need to treat that 3 as a... What sign's right in front of it? A negative. Treat this like a negative 3 when you distribute it. Negative 3 times 6x would give me what? Negative 18x. Negative 3 times negative 11 gives me, careful, negative times a negative makes that a positive 33. Unfortunately, with these problems, if you make one little error with positives and negatives, like making that 33 a negative on accident, it's going to throw off the whole problem and you will likely get the whole thing wrong. Okay? So be careful with your signs. Combine like terms, negative 2x minus 18x. Dominic?
Negative 20.
Negative 20x plus 33 equals negative 7. My next step, trying to get x alone. What should I do? Subtract the 33 on both sides. Negative 20x equals negative 40. Last step. Divide. What do we get for x? Negative divided by negative is a positive 2. Okay, again, one sign error is going to throw off the rest of the problem. We're going to take that 2, and where are we going to put it? Back to the original problem for x. All the way back up here. So that leaves me with y equals 6, parentheses 2 minus 11. 6 times 2 is? Minus 11 is 1. Okay, so our ordered pair, I'll write it off to the left, is 2, 1. Questions about example 5? In my opinion, example 6 is the easiest problem we've seen so far. On example 6, what's different or special? Liam, what do you think? Y is only a number. They already solved for y for you. They gave it to you right away. This makes our life a whole lot easier. We are still going to take it and plug it into y in the other equation, but what this means is that you were given half of your answer from the very beginning. If y is equal to negative 2, you can go ahead and fill in a negative 2 for y in your ordered pair. Which means after we plug it in and find x, we're going to be done. We don't have to then go back to the beginning to find y. They already did it for us. So, 4x minus 3 parentheses negative 2 equals 18. What's happening with the minus 3 and the negative 2?
They're turning to positive 6 since they're both negatives.
Good, we're multiplying them. Negative times a negative makes it a plus 6. The parentheses are important so you remember to multiply. You're not just subtracting. Next, we need to work on getting x alone.
Subtract 6 on both sides.
Good, and then?
And then you get like 4x over 4 equals 12 over 4.
Good, divide by 4, so we get x equals 3. That can go straight up into our answer that we'd already started building. So if they give you a variable equal to a number right away, that makes your life a whole lot easier. Questions about example 6? Need more time with it. Moving on. All right, example 7 switches gears just a little bit. Anybody see why I say that about example 7? Wyatt, what do you think? Good, x is alone instead of y. That doesn't change much about our process, except for the fact that this is now getting plugged into x instead of getting plugged into y. Make sure you're paying attention to which variable is alone so you know where to put it. So 2 parentheses plus 4y equals 12. In those parentheses, I'm putting the 3y plus 1. At this point in the problem, if you were to see an x and a y in what you wrote, you did something wrong. At this point, you should only have one variable so that you're able to solve for it. When you distribute, what do you get? 6y plus 2 plus 4y equals 12. Combine like terms. 10y plus 2 equals 12. Subtract on both sides. At this point, it should almost be like muscle memory. We did this a lot last semester. We're going to do it a lot this semester. Last step to get y alone. Divide by 10. Y equals 1. Are we done? No, we only found y. We still need to find x. So we take that y back up to the very beginning and plug it in. So this time x equals 3 parentheses 1 plus 1. 3 times 1 plus 1. How would I write my answer? 4 comma 1. That's the tricky part about when they start you off with x. Your ordered pair should be x comma y. That's why I said it doesn't matter what you found first or what you found second. X goes in the front, y goes in the back. All right, I want you to try at least number 8 on your own. We'll talk about it in just a couple minutes. If you want to look at 9 and 10 as well, that's fine. 9 and 10 are special situations, but you could at least get them started. Anybody get an answer they want to share?
2 comma 3.
2 comma 3. Anybody get the same thing? A few people did. Good. Okay, what we should have done is take this expression and plug it into y. Negative 3x minus 2 parentheses 5x minus 7 equals negative 12. Distribute. You need to treat that 2 as a negative 2 when you distribute to get your signs right. Should have ended up with negative 3x minus 10x plus 14 equals negative 12. Combine like terms. Negative 13x plus 14 equals negative 12. Subtract the negative, or subtract 14. Negative 13x equals negative 26. Divide by negative 13. So at the very least, I agree that x equals 2. Questions about getting x? Okay, getting your first one is usually the tricky part. Getting your second one should come easily. You take that number, you go all the way back up to the top and plug it in for its variable. That means we would have y equals 5 parentheses 2 minus 7. 5 times 2 is 10. 10 minus 7 is 3. So I agree your answer is 2, 3 as an ordered pair. Don't be pulling phones out in my classroom. Questions about number 8? Okay. Number 9. What's special about number 9?
Oh, this is same thing.
They're the same thing twice. So, some of you might already know this from yesterday when we graphed. We could technically treat it like one of the ones we did today, even though we notice it's going to look a little funny. 13x plus 1 equals 13x plus 1. If I ignore the fact that this looks awfully silly and say I want all my x's to be on the same side, that would mean I would subtract 13x, which means I have to do it on the other side. So what happens to my x's on both sides? They cancel out completely. X is totally gone. And what are you left with?
1 plus 1.
Not 1 plus 1. 1 equals 1. We had a positive 1 here, positive 1 there. 1 equals 1. Is that true or false? That's true. If you end up with your variable canceling out completely, it is gone, and you get a true statement, then you have infinitely many solutions. It's just like when we graphed yesterday and you graphed the same exact line 2 times. Same thing here. We haven't talked about it much, but any problem that we did today, we could have done by graphing like we did yesterday. Any problem we did yesterday with graphing, we could have done with substitution today. We are learning multiple ways of doing the same types of problem. Number 10, let's start it off the same way. We are going to take this negative x minus 5 and plug it in to y in our other equation. If I want all of my variables to be together, what am I going to do? Add an x. Do it to one side, do it to the other. What happens? They cancel out completely. Gone on both sides. What are we left with on the left side? Equals. What do we think about that? Do we agree with it? No, we should not agree with negative 5 equals 4. That is false. It's not true. Doesn't work. So what do you think that means for our answer? I think somebody whispered. Wyatt, what do you think? There is no solution here. There are no XY ordered pairs that will work in both systems at the same time. Those are our special cases. Questions about the special cases? All right, this last problem we're going to talk about briefly. You don't necessarily need to write it down. We've got snowman minus reindeer minus reindeer minus reindeer equals -1. Let's put a plus sign in between here. Snowman plus snowman. And we've got snowman is equal to reindeer minus 1. Okay, you might have seen something similar to this on social media before. These picture puzzle math problems have been popular in the last few years. Most adults that I see that try them get them wrong. Instead of using a snowman, let's use a variable. What variable do you want to use? X. How many snowmen do we see here? 2 of them. So I would put a 2x. What variable do you want to use for your reindeer? A y. So if I've got minus, 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 what do you think I'm putting here? Minus 3y equals that -1. The other one, again, we said snowman is x, reindeer is y. So then we would be able to take, well, so this is a little bit different than what we've been doing, but you will see this on your homework, so it's a good thing we brought it up. Which one of these is solved for a variable? The x is alone. It's in the bottom equation. That's fine. That just means that we're going to be plugging the y minus 1 into the top. So on any of these problems, if they had put it on the bottom instead of on the top, you would handle it the same way. Okay, we won't walk through the end of that problem, but I wanted to show you how we could set it up, and the fact that even if this x equals is on the bottom, now you're going to plug it in up here instead.